So we're going to talk about the unit circle today, okay? So that is the heading. At the top of your page. And you need to draw a big circle. So firstly, I want you to draw a coordinate plane. And it should be fairly large. I know some of you guys like to draw really small. This is not the time for that. Okay? And then I want you to draw a big circle on that coordinate plane. That's not bad. I've done better. I think I'm better not on the smartboard, to be honest. I feel like it's more free when I can draw on the whiteboard or on chalk. I give myself like a B-. Well, okay, I don't know. I think I'll stop. Okay, so are we all good? Yeah? Okay. The unit circle is a circle of radius 1 that is drawn at the origin. Okay? Okay, so radius is 1. This is the point 0, 0. And it's drawn at the origin. So let's just draw a couple of points in here. We know over here that this is the point 1, 0. And this over here would be the point 0, 1. This over here would be the point -1, 0. And down here, we've got the point.
Please excuse this interruption. Can we have any grade 12 students with last name A through G, as in George, if you can make your way to the Ox Gym, if you are looking to have the rapid test being done? Thank you.
0, -1. Okay, so I'm going to leave that for a moment. And what we're going to do now is, again, I know I'm going to sound a little bit like a refrain here. We're going to just revisit our special triangles, okay? So we have the 30, 60, 90 triangle, comes from the equilateral triangle with a side length of 2. And we can bisect that, which means this is 60, this is 30, this is 90. Right? Now this is 1. This is going to be the square root of 2 squared minus 1 squared, which is the square root of 3. Okay? So we have this. 60, 30, 2, 1, root 3. Okay, we've seen that before. And then again, I'm not going to draw the whole square, but the isosceles right triangle comes from drawing the diagonal of a square with a side length of 1. And then the hypotenuse is square root of 1 squared plus 1 squared, which is the square root of 2. Okay, so based on these triangles, we can get all of the trig ratios that we want. For example, if I wanted to know the cosine of 30 degrees, I could see that it's adjacent over hypotenuse, root 3 over 2. Okay, nothing new there. Okay, now back to the unit circle. Yesterday, we looked at the fact that we can take the trig ratio of any angle, and we redefined those trig ratios instead of opposite over hypotenuse for sine and adjacent over hypotenuse for cosine, etc. We redefined them in terms of x, y, and r. Okay? Now, in this unit circle, what's the radius? 1. So I'm specifically today, we're going to only be looking at sine and cosine, okay? Sine and cosine. Sine was y over r. For the unit circle, if r equals 1, the sine of any particular angle is going to be the y value of where the terminal arm intersects the unit circle. It's just going to be y. Cosine was x over r. And again, if r equals 1, the cosine of a particular angle on the unit circle is just going to be x, the x value of that point, where the terminal arm intersects. Okay, so now what I'm going to do is I'm going to draw some angles on this triangle. So the first angle that I'd like to draw is this one, the one right in between between 0 and 90, which is 45 degrees. And I want you to draw it too. Okay, so this is 45 degrees. Okay, now let's go back to our special triangle. Here's 45 degrees. What is the sine of 45 degrees? Sine of 45 degrees. You guys can all chime in. 1 over root 2. What's the cosine of 45 degrees? Also 1 over root 2. So back to our unit circle. This point over here, because the radius is 1, the x-coordinate is the cosine of 45 degrees, which was 1 over root 2. I'm going to erase, hold on, I don't have a lot of space here. I'm just going to erase this. Let me draw that better. Okay. The x-coordinate is the cosine of 45 degrees, because remember, it's x over r, and r is 1. So this is 1 over root 2. And the y-coordinate is the sine of 45 degrees. That was also 1 over root 2. Okay, now, sine is positive in which quadrant? Which other quadrant? Yep. So that's this angle over here. Okay, so because sine is positive, sine is the y value. The y value is also going to be 1 over root 2. Or sorry, I'm drawing in the x value right now. But in the second quadrant, cosine is negative, right? Still has the same reference angle because this over here is 45 degrees, right? This guy down here, 45 degrees. The cosine would be negative, though, because the cosine is not positive in the second quadrant. So the x-coordinate, which is the cosine of this particular angle, is negative 1 over root 2. Okay, now that particular angle is not 45 degrees. It's 180 minus 45, which is 135 degrees. Okay. Okay, let's keep going. In the third quadrant, oh, that's terrible. Hold on, I gotta do that better. That doesn't look like 45 degrees at all. I have to do this when I'm standing right in front of it. Okay, that's better. Okay. In the third quadrant, sine, cosine, what are their signs in terms of positive or negative? They're both negative, right? So this point down here is going to be negative 1 over root 2, negative 1 over root 2. And this angle, by the way, again, we're using the same reference angle for all of these. The reference angle for all of these angles that we're drawing is still 45 degrees. But this one, because it's in the third quadrant, is 180 plus 45 degrees. So this particular angle is 225 degrees. And then finally, we'll draw this one. And this over here is in the fourth quadrant. Here, cosine is positive, but sine is negative. So our x-coordinate is going to be positive, and our y-coordinate is negative, right? So this is going to be 1 over root 2, negative 1 over root 2. Now, you can also kind of see using symmetry and the fact that you should know the sign, and I mean not the trig ratio sign, but the positive-negative sign of x, y coordinates in each quadrant. So you can tell that way as well. Okay, now this angle is 360 minus 45 degrees, because again, we're still using the same reference angle. So this guy over here is 360 minus 45, 315 degrees. Okay? All right. Let's try this for another angle. Let's move on to 60. Or actually, no, I'm going to do 30 next. Let's do 30. That's a smaller one. Let's look at 30, okay? There's 30. What is the sine of 30 degrees? Don't be shy. Sine of 30 degrees. 1 over 2. The cosine of 30 degrees? Root 3 over 2, right? Opposite over hypotenuse, 1 over 2. Adjacent over hypotenuse, root 3 over 2. Okay? Now remember, cosine is the x-coordinate, sine is the y-coordinate. We can only get away with that because it's actually x over r and y over r, but in this case, because we're talking about the unit circle, r is 1. So it's just the x-coordinate and the y-coordinate. Okay, so if I draw in a 30-degree angle, now I think I may do this in a different color. Okay, so here is 30 degrees. Ooh, that's very thick. Hold on.
Please excuse this interruption. Can I have any grade 12 student with last name H through L? If you are wanting a rapid test done, could you please make your way to the Aux gym? That's grade 12, last name H through L.
Okay, so this point is going to be x-coordinate is cosine 30, y-coordinate is sine 30. Cosine was root 3 over 2. Sine 30 was 1/2. Okay, now let's fill this in for all of the other angles that use 30 degrees as the reference angle. Okay, so in this quadrant, this will be 180 minus 30, which is 150 degrees. Now I'm not going to do the whole thing. I'm just going to write 150 over there. Okay. Here, x is negative because cosine's negative. Y is positive because sine is positive. So this point over here is going to be the point negative root 3 over 2, 1/2. Okay. In the third quadrant, okay, this will be 180 plus 30 degrees, which is 210. And this point, oh, I didn't put a bracket there. Okay, this point here, both of them are negative. Sine and cosine are both negative. So the x and the y coordinate here are both negative. This is negative root 3 over 2 and negative 1/2. And then finally in the fourth quadrant, this angle is 360 minus 30, which is 330 degrees. And here, cosine is positive, sine is negative. So this will be root 3 over 2, negative 1/2. Okay. All right, one angle left, and that is 60 degrees. Okay, what's the sine of 60 degrees? Sine is 60. Don't be shy, guys. You can all chime in. Root 3 over 2. What's the cosine of 60? 1/2. Yeah, so they switch, right? Cosine and sine switch, and that's what happens in all triangles when you have complementary angles, right? When the angles add up to 90. Okay, so basically what's going to happen is in all of those 30-degree, for all of those 30-degree angles, the x and the y coordinate are just going to swap. Okay, so we can now fill these in for 60 degrees and also all of the other angles between 0 and 360 that use 60 degrees as their reference angles. Okay, so I'm going to do another color. This time I'll remember to make this smaller. Okay, so here's 60 degrees. And this is now, cosine was 1/2. Oh, sorry, this point rather was 1/2, and sine was root 3 over 2. Okay. This angle over here, there's a lot of symmetry that's going on, right? Okay. Well, you guys can see because I'm using different colors, hopefully. That point over there, okay, sine is positive, cosine's negative, so x will be negative, negative 1/2, root 3 over 2. And this angle will be 180 minus 60, which is 120. This one over here, that point right there, they're both negative. So this will be negative 1/2, negative root 3 over 2. And this angle is 180 plus 60 degrees, which is 240 degrees. And then last but not least, this angle over here, cosine's positive, sine is negative, so our x coordinate will be positive, 1/2, y-coordinate will be negative root 3 over 2. Okay? And the angle, by the way, is 360 minus 60, which is 300 degrees. Okay? Now, the other thing I should mention is that, and this is why I'm glad that I was asked about question 10 on the homework from yesterday. These points that are actually on the axes give you the sine and the cosine of those angles as well, right? So, for example, if you're looking for the cosine of 0, that's equal to 1. It's the x value. The sine of 0 is equal to 0. That's equal to the y value. Okay? If you want to know the sine of 270 degrees, that's the y value over here, -1. Okay? So just by looking at the x and the y coordinates along these points, then you basically have everything that you need to know. Okay? Now, this is actually not an outcome in 20-1. This is an outcome in 30-1. But we like to introduce it here because it ties really nicely in with angles in all 4 quadrants and in special triangles, which we do in 20-1. And in 30-1, I'll show you the sheet that I'm going to hand out tomorrow, which is here. We're going to add in this stuff where you see pi by 6, pi by 4, pi by 3, all that kind of stuff. Here you got 11 pi by 6, all that kind of thing, okay? So you know how I always tell you guys to switch your calculators into degree mode? Okay, so this pi by 6, 5 pi by 6, all that kind of stuff, these angles are measured in radians. We're going to throw that into the mix as well next year. So everything that you've been doing with trigonometry so far, up to this point, next year you're going to do all that and more in radians instead of in degrees. So it's basically another unit of measure for degrees. And in the field, that's the one that's used. It's not, we don't use degrees in the field of mathematics. Okay, we only use radians, which is why that's the default on your calculator. Okay, so if you see this first, which you have enough already with the knowledge that you have right now to be able to see the unit circle, then it's not going to be as much to absorb next year, right? And you're going to be asked a lot of questions around exact values of this kind of stuff. Now, I got to tell you, a lot of people spend a lot of time memorizing the unit circle and literally like tattooing this to the memory of their brain so that they can, like, I'll be like, what is the cosine of 11 pi by 6? And they will like close their eyes and think and think and think and then be able to come up with it. I could never, ever do that. I've never been able to do that in my life. The only thing that I ever remember, ever, are special triangles. Because if I have my special triangles, then I have everything. If I remember special triangles and I remember cast, I don't even need the unit circle, right? I can come up with all of these trig ratios in seconds, right? I got my special triangles, cast, piece of paper, I'm there, right? But it really, really just depends on what you like. There's a ton of memory tricks that all sorts of people go through to try and memorize this. You do need to know all of these trig ratios in radians with exact values next year. So you will be asked to solve, for example, trig equations, right? It might look something like this. You might be asked to solve something like this, for example. Let me think.
Please excuse this interruption. Can I have any grade 12 student with last name M through Z? If you could go to the auxiliary gym if you're looking for the rapid testing. That's grade 12 with last name M through Z. Thank you.
I'll make it in degrees, something like this. In exact values. This is a very typical type of question next year. So we actually have enough knowledge right now to be able to solve this, and I can show you how to do it if you want. But no, some of you are like, no. It's not really as scary as it looks, but to do it, you need to know about these special triangles, you need to know about cast, you need to know, some people like to do it only using memorizing the unit circle. As I said, the only difference next year is that this will be from 0 to 2 pi, as opposed to 0 to 360 degrees. Do you guys want to look at it? Do some of you want to look at it? Yeah? Okay. So the idea here, cos squared theta is the same as this. It's the same as that. So when we're trying to solve this question, essentially what we can do is a substitution where we sub in an x for cos theta. And then what we can do is look at this instead. We look at that instead. Yeah? What would you do here? What do you think? What's that? What kind of equation is this? Quadratic, yeah. Factor it, yeah. We can factor this. Okay, so these have to be a 2x and an x. It's the only way to get 2x squared, right? And the only way to get minus 1 is a 1 and a negative 1. It's just a matter of where does the negative sign go? So this has to be a plus, so I need to have plus 2x minus 1. Yeah? Okay, so now I'm going to have 2x minus 1 equals 0, x plus 1 equals 0, which means that x equals a half or x equals negative 1. Now we sub cos theta back in for x, because that was what was in the original equation. So we have cos theta equals 1/2, cos theta equals negative 1. Okay, now we have to think to ourselves, okay, cos theta is positive. What quadrants? 1 and 4, that's right. Okay, what angle has a cosine of 1/2? It's the other thing we have to think about. So at this point, personally, my strategy is not to think of the unit circle, but to start to draw this. 30, 60, 90, 1, root 3, 2. What has a cosine of 30 degrees? Or sorry, what has a cosine of 1/2? I gave it away. It's 30 degrees, right? So the reference angle is 30 degrees. So I would do this. So one of the angles, because cosine is positive, is in quadrant 1. Okay, so that's one angle that has a cosine of 30 degrees. Okay. The other one's in quadrant 4. Well, this is our reference angle. Our reference angle is 30 degrees as well. In quadrant 4, to get our angle, we go 360 minus the reference angle. So the other angle is 360 minus 30, which is 330 degrees. That's two options. Now to get this one, you may actually here want to think around, okay, the cosine is the x-coordinate, right? So where on the unit circle is the x-coordinate -1? It's right here. What angle is that? 180, right? So from here we get that theta equals 180 degrees. So the solution to this equation, there's three solutions actually. The solutions are theta equals 30, 180, and 330 degrees. Okay, so that's a typical type of 30-1 question. Kind of relatively simple level. Well, no, I would say between easy and medium type question. Okay, so yeah, we like to sort of introduce this now because next year, trig is just so much to take in. Yeah? Okay. And as I said, there is just so much. I mean, listen, you can use whatever strategy you want. You can memorize this if you want. And again, I will give you a copy in case, because I know sometimes it can get messy when you're drawing it out. So that copy the printed one that I showed you a minute ago, I'll print that for you guys for tomorrow. Some people like to memorize it. I don't know. I think it's just maybe it's whatever you grew up with. I always grew up with special triangles and casts, so that's just my personal strategy. Okay, but yeah, that's all we're gonna do for today. So I'm gonna stop this right now. You guys